All right. Cool. Sounds like this is working. Hi, everybody. To, Today I'm just going to be giving a quick lightning talk on one of the issues we've dealt with while building Korifi. And that issue is eventual consistency. So before I begin, let me just introduce myself real quick. Hi, I'm Tim Downey. I'm a staff engineer at VMware and a Korifi improver. And I've been working with Cloud Foundry for about the last 6 years now. So to start with this, let's look at that classic CF command, CF push. So to Cloud Foundry developers, CF push is just a single command that gets them from source code to running application in like one step. But if you look under the hood, you'll see that the CF CLI is actually making dozens of individual requests to the API in quick succession. So like it will configure the app, set up routes, stage the app, and finally start it. And each of these operations relies on the previous one succeeding and for the API to behave consistently. So to demonstrate this, we're going to look at one sub-step there, which is creating a build to stage the app, which is like what we saw in the last demo. So to do this, the CLI will first send a post request, and it will get back a 201 status saying that it was created from the Cloud Controller API. Then, to see once it's done, the CLI will just like continuously pull the API, and it will expect to get 200 requests back, or response back, with a body containing that build and its current status. And in CF for VMs, that works pretty well. But now we're going to see a similar flow, but using the Korifi API. Well, at least a Korifi API with no mitigations or anything in place. So as before, the CLI, it doesn't know what it's talking to. It behaves the same. It will send that post request and create the build. And the Korifi API will, again, respond with the 201, assuming it was able to create that CF build custom resource, of course. Then the CLI will just immediately start polling. Only this time, maybe it might get a 404 not found error, and that's not good. So normally in CF for VMs, a 404 should only occur if you don't have access to the resource or if it was deleted or something. But in this case, you could imagine it just happens, and the CLI might try again and get a 200 back. So what's going on here? This is eventual consistency, at least one symptom of it. So in this case, even though the Korifi API created that CF build resource and it was successfully written, subsequent reads weren't returning it immediately, but eventually it was returned. So to understand this better, we're going to dig behind the scenes and see what's going on between these two environments. So in CF for VMs, that post request is translated into an insert build operation on the database. And of course, once that's committed, the Cloud Controller can be pretty certain it is committed and return that 201 back. So then when the CLI starts polling, like it's going to be there. And this is because CF for VMs usually either has a single instance of that database or uses like a more advanced like HA multi-cluster DB such as Galera that provide pretty strong read after write guarantees. And now let's compare that to what's going on with Korifi. So as before, the CLI is creating that build. Then the Korifi API has to translate that into a CF build custom resource and send it to one of many Kubernetes APIs, which in turn are talking to one of many etcd nodes, which will persist that. So like ideally, this write to one of those etcds would be propagated to all the others immediately. But in practice, there is some delay, typically a second to maybe even more. And because of this delay, when the CF CLI tries that get, it might hit a different etcd than the one that was written to, and that one will not know about that build. So that's the cause of our 404 here. And yeah, that's one of the causes at least. So why the difference? So of course I've mentioned etcd already, and that's the main culprit here. But how is it so different? So etcd is a distributed data store, uses RAF consensus algorithm like many other distributed systems out there these days. And it guarantees what we call sequential consistency. So reads across the various nodes are guaranteed to return results in the correct order, but not necessarily at the same time. So there's no guarantee that as soon as you write something, all the other nodes will learn of it immediately and return that result. But once they eventually learn of that result, they're guaranteed to return all these writes in the correct order. And in addition to etcd, of course, it's less performant than a traditional database, so there's just tons of layers of caching across the board. So there's most likely multiple Kubernetes APIs. Each of those APIs is maintaining its own etcd watch cache. The Korifi API uses Kubernetes clients, which maintain their own caches. There's tons of caches, which all have an opportunity to be slightly out of date. So in short, there's just a lot of places where consistent state will eventually trickle out, but isn't there immediately. And of course, there's a few other issues that are not necessarily due to etcd, but can result in these types of things, such as lag when changing user permissions, like the time it takes for RBAC to take effect on the Kubernetes API or for our controllers to propagate stuff. And we don't have the same ability to do transactions across multiple resources like we do with a traditional relational database. So the Kubernetes API lets us manipulate one CRD at a time, basically. So we have to either like roll back things ourselves or like just time things pretty well for stuff to shake out perfectly on the CLI. And of course, we don't have the same kinds of synchronous callback mechanisms that CF for VMs has. So typically, Cloud Controller is able to provide like task callback endpoints and stuff when it's staging with CF for VMs, and we don't have that. So we do the Kubernetes pattern of having continuous control loops running and watching things over time, and those also add delay. So there's a few things we can do. We can mitigate it within our Korifi API. We can retry and rely on idempotent resources. And we can also just like embrace eventual consistency, essentially. So how do we mitigate it in the API? One thing we do often is delay API responses. So we know the CLI is going to try to fetch something immediately. So the API can wait to respond a little bit and check resources and make sure that they've at least been reconciled before it continues. And like this isn't 100% going to work all the time, but it definitely increases the likelihood that things will work fine. And additionally, like I mentioned earlier, we can rely a lot on retries. So the CFCLI is already set up to retry. It's actually pretty nice. In that case I mentioned earlier, a 404 will trick it for sure, but most other endpoints, it has polling behavior built in, and it's going to wait for statuses on resources to match what it wants before it continues. And like I also mentioned, our controllers behind the scenes are also just using the same Kubernetes frameworks as the built-in controllers and requeuing and retrying constantly. And that allows us to essentially wait for these resources to get ready. So here's just like a simplified example of how this all looks in practice. And as you can see, there's just like retries and waiting all over the place here. So like the Kubernetes API itself is subscribing to etcd's watch endpoint for all the resources and watching events. This way, it will eventually be notified of things as they happen. Our controllers then subscribe with a watch to the Kubernetes API, and they'll periodically requeue even to resync and update the status fields on all these resources for clients like the CFCLI to pull us through the Korifi API, which will eventually see these statuses. And I've been talking about statuses a lot. So this demonstrates a little bit more of what I mean there. So this build is created with an empty status, essentially. It's eventually reconciled by our controllers and populated with some unknown statuses. This is really handy because then the Korifi API knows it's at least been looked at by something and can assume that it's more likely to be persisted across the various SDD nodes. At this point, it's probably safe to return and let the CLI begin its polling. And then at the end of staging, for example, the build will be completely full with information about that built image and ready to be returned as a completed build back to the CLI. And then the CLI can just pluck droplet information off of it, essentially. So yeah, I know I'm running late on time now, but fortunately, we're about done. So if anyone has questions about this, I'm more than happy to talk about them now or after. Just hit me up in person or on Slack. But there's a lot here, and it's fun. All right, well, thank you.